Hi everyone, I'm at the AI Networking Summit. We're recording a couple of Built for Trust podcasts. I'm also about to be joined by Vishal Shukla. He's over at Aviz Networks. So these guys are really pretty cool. They are kind of doing kind of a management overlay on top of the fabric to make sure that Ethernet fabrics get a lot of the new feature sets that are required within AI infrastructure. So they're about to make they did make a big customer announcement. So we're going to dive into that for a little bit. So plug in and enjoy. Thanks. Welcome to the podcast. So happy to have you here.
Thank you, Nick, for inviting me here. It's been a great show, and the theme has been very well aligned with what we do at Aviz.
Oh, how awesome. I'm really happy to hear that. Yeah. So I know that I heard that you guys have made a customer announcement. Yeah. First of all, Aviz, let's talk a little bit about Aviz. You know, it's kind of like make sure everybody knows what you guys do and where you participate in the marketplace. So let's start with that.
Sure, yeah. So Aviz Network, essentially, we are working on bringing AI into networking, and the way we see it is essentially on the two dimensions. The first dimension is making networks for the AI workloads, so that's networks for AI.
Yep.
The second dimension is essentially putting AI in use to make networks more efficient, right? So that's where the network co-pilot kind of a technology comes in to essentially be able to manage networks more efficiently in a vendor-agnostic way. So these are the two dimensions: networks for AI and AI for networks.
Okay, very good. So let's. So before we talk about, there's a customer announcement that I really want to get at. Let's first talk about network for AI.
Yeah.
And Aviz's focus there. Like, where are you focusing?
Yeah, so essentially if you look at the difference between how the networks are being designed for the AI workload, it requires some of the key protocols which goes into as deep as the buffering and as deep as the port speeds and everything, right?
Yeah.
It needs some certain protocols, which is RDMA over converged Ethernet,
right. Yep.
To make it work right. Now GPUs are a very expensive, the compute and those kind of things, but the network has to play along with that. So the network has to be tuned right. And so that there is no traffic is getting dropped, right? That comes from the RoCE, which is RDMA over converged Ethernet. And then the speeds are increasing from 400 gig to 800 gig, coming from various different ASIC vendors.
Going to 1.6,
Yes.
Probably within the next 18 months.
Definitely.
Yeah.
So there is a need for a unified fabric manager, unified observability platform on top, which actually makes sure that your networks is fine-tuned for those heavyweight GPUs, right?
Yep.
And there is a recipe to that, right? So this customer who we announced yesterday is actually making a GPU as a service cloud, essentially giving out a GPU as cloud as a service to the customers. And the network is a very important piece there, because if you are putting those expensive GPUs as the workload, the network has to work right, and also it has to be future-proof. Like 1.6 you mentioned coming in 18 months. So how do you make a system wherein the network just delivers, right? So that is what we specialize on, to make sure that the Ethernet fabric is fine-tuned, performance optimized for those kind of GPU workloads.
That's really great. So there's a whole bunch of requirements like within the network fabric piece.
Yeah.
Obviously there's kind of like the last tail latency, which is an important component in here. Congestion management is also really important. Oversubscription, because in Ethernet we don't have railing, between GPUs. So I mentioned congestion management. You already talked about RoCE.
Yes.
In that particular environment. There's probably a few others. Oh yeah, like elephant, flows,
and the mice flows,
in here, as well. So your kind of management system of the fabric is really to kind of enable that, and to put those features into the fabric so the fabric can actually scale.
Yeah, and do
scale out.
Exactly, and do it in a vendor agnostic manner.
Yeah.
Normalize the data set. And essentially, first of all, not just orchestrate, but observe it and put the anomaly detection on top of it, so that if there is any anomaly happens for the elephant flow, mice flow, buffer running out, latencies are not doing good, those anomalies can be reported. And not only that, put the AI on top of it to start the prediction on what kind of flows are behaving in what ways and what are the prescription for not to have that problem again in your network.
Oh my God, I love that.
So,
really, so it's AI trying to manage the AI infrastructure.
Exactly. That's the tagline, right? I mean, the networks for AI and AI for networks.
Oh my God,
that's where
so
it meets.
All right, so you had a customer announcement, right?
Exactly.
So let's talk about that.
Yeah. So this the meritorious rights of NVIDIA with all the GPUs and everything, which kind of gives a clear signal that pretty much all the industry verticals are looking to apply AI in some way or the other, which actually have given this rise for this deploying GPUs in various shapes and form. So some of the ways that these vendors are making their own clouds, and in some of the ways they are going to take cloud as a service, so GPU as a service for that matter, right? So you see, I mean, NVIDIA GPU-based clouds are coming up, and then there is AMD MI 300 accelerator-based cloud coming up, and this market will keep on growing, right? With the attachment of this new greenfield GPU deployments, you see the networks are also getting attached, because without networking, you cannot connect, right? So this particular customer was looking for making a future-proof, networks, so that it grows with the power of the GPUs as it grows in the future, right? So TensorWave is a very future-looking GPU as a service provider.
What's the name again?
TensorWave.
TensorWave.
Yeah.
Okay.
And we've been working for past couple of months to essentially design the network. First of all, what will be the best design for that network? Then essentially what will be the parameters to manage the network, right? And then how do you make it future-proof for right now 800 gig networks? How does it go to 1.6 terabytes? And then it grows with the speed of the GPUs. It grows with the demand. So the future-proof part of it. So all of those elements were taken care by the fabric management system, the observability system, which is Open Networking Enterprise Suite, designed for a vendor agnostic way. So that's where the path aligned, and as I said, that this thing is moving very fast. So that is what the deployment was, very fast. And now we are just looking for future to have more and more GPU as a service cloud vendors making the networks in the same way, vendor agnostic, which is designed for future. Yeah,
okay, well that's really an important point. So one other quick question. So on the fabric itself, does it matter if it's InfiniBand or if it's an Ethernet fabric?
I mean, if you look from the NVIDIA point of view, they have these two offerings, the InfiniBand as well as the Ethernet. There is a difference between InfiniBand and Ethernet. Obviously, InfiniBand, as per NVIDIA, has some performance advantages and everything, but then there are certain functionality things that is a single application. You cannot have multi-tenant and all these kind of things, which Ethernet has ways to take care of that, right? So essentially, there will always be this debate, InfiniBand versus Ethernet, but we see a good traction on the Ethernet side because of certain use cases which cannot be done on InfiniBand, and that's where I think the scale and the future of this GPU as a service gonna go, because this InfiniBand and Ethernet is not a new battle, by the way. I mean, before GPUs, it was there from past, since Mellanox came into the picture. So it will stay there, but I think the growth will be more on the Ethernet side.
I'm with you on that. I think like on the Ethernet side, that allows us to kind of democratize that infrastructure. It also, there's a lot of different companies who can now contribute and add the feature set to Ethernet, so that it can actually not only just address those unique requirements that are within the fabric, but also expand over a period of time. You have a lot more companies placing resources and a lot of smart people to work on that Ethernet fabric. Well, you don't have that on the InfiniBand side.
That's right.
I mean, so it's like, I don't want to knock the InfiniBand, folks. They did a really great job, and kind of they brought us a lot of really great technology. But I think that's like it's a maturity curve, that we're now kind of moving into.
And the other point here is that how big is the ecosystem? Right. I mean, Ethernet. You have huge, so many vendors. You have the ecosystem of all the ASIC vendors, switch vendor. While in InfiniBand, you have just one vendor. And all the respect to NVIDIA, but the ecosystem is bigger on the Ethernet side. It's always have survived all these waves and everything. That's so I think the future is Ethernet, but let's see.
Okay, I'm pretty sure. Excellent. Vishal, thank you so much. I think that was like just really great. Congratulations.
Thank you very much.
On the announcement. Love the focus, as well. So is there anything else that you want to kind of touch on? I thought that was a good place to stop.
I mean, AI in networking, that's the theme of ONUG. We see that it's going to grow in coming months and years. We are just here making sure that AI is actually going in two different dimensions, making networks and managing networks. So that's what our focus is, and you'll see more and more coming onto these two dimensions.
Okay, awesome. Okay.
Thank you very much, Nick.
That's a better place to stop. Awesome. Vishal, thank you.
Thank you very much.
You're more than welcome. Great.